cents here. 1:51 p.m. Central Time on Saturday, January 3rd, 2015. And we're looking at Earthquake 3D here, which is the USGS feed of the most recent earthquakes. And I want to draw your attention to a earthquake which occurred here in the Pacific Northwest in central eastern Idaho. And it started out as a 5.1 magnitude earthquake. Several of my viewers contacted me, and I've been debating whether or not I should even still cover earthquakes based upon the response that I've been getting lately, but decided it's probably a good idea to actually do a video on this. Let you guys know. I'm going to bring you over here to my website really quick. And I did a post on the 1st, so New Year's Day, did a post when we had the earthquakes that happened here off the west coast, off northwest California, and it turned out to be a 5.4 revised, and then a 5.2 struck right after that off the coast of Vancouver, British Columbia. And this led me to make a long post letting people know that we were watching for this to happen. But in the post, I said, okay, now that this has happened, we need to watch Idaho, Montana, Wyoming, and Colorado, Arizona, Texas, Oklahoma, Kansas. But first, need to watch Idaho, Montana, Wyoming for this movement to occur, this new movement that's been happening. It kind of, I don't want to say it turns all of geology on its head, but it turns a lot of what is thought about geophysics processes on its head. And what's happening is earthquakes are actually spilling, pressure transfer is occurring across a large area, from one area to the other, causing earthquakes in both areas. And to top it all off, it's happening in the opposite direction than normal. Now let me show you what I'm talking about here, okay? So here's our two big earthquakes that happened over the last few days. We're looking at the last 3 days of earthquakes. And you can see 5.4 here, 5.2 here, and then now today, the 4.9 here. But if I take the earthquakes down a notch so you can see the smaller earthquakes, then you'll see a whole swarm and a flurry of earthquakes that kicked off along the south and western, partially western, edge of the Craton at the fracking operations. And just to show that to you here, let's look up the largest Texas earthquake here. Texas being one of the states named in my warning here. And this was several days ago now, right? Okay, so let's get the coordinates from the USGS on the 3.2. Okay, Snyder, Texas. Now, for those of you who have paid attention in the past, you've already know what's there, but this is for the new viewer. This is for maybe a geology student or a professor who was in denial that fracking operations can cause earthquakes or that the Craton can be displaced from the west. So we zoom in here. Here's the coordinates of the earthquake, and look what's right here. I mean, this is an area where I've already marked earthquakes from other previous events. Here's a 2.6 from May 6th. And what do we have here right at the center? And this is part of a larger operation. When we back this out, you can see this goes down. The deposit of oil and shale is given away by where the operation is. And that goes down further. Look at this. Each one of these, if there's any doubt in your mind that these are oil well fracking operations, I'm going to zoom in randomly on any one of these. And what you'll see is the wellhead apparatus. A lot of times, a lot of the piping for this is done underground, and then you'll have a nearby compressor station that gathers it all together, and finding those is kind of hard. Perfect example right here. Okay, you see these pipelines coming in. These pipelines come in from all over, and then they're fed into here, which then goes into another pipeline that's pumped out. And, okay, here, perfect example. Here's the pipeline coming up out of the ground, either heading to or from that compressing station. So, and overall, then it goes to a larger area, which then collects it. Look at this. Same thing, just much bigger, and a much bigger pipeline. So you hear them talking about oil shale, the huge competition that's going on between Russia and Saudi Arabia. Well, this is causing earthquakes here in the United States. Now, why are there earthquakes happening there? They said this could never happen, that fracking couldn't cause moderate to large size earthquakes. And we've seen over the last several years 5.0 earthquakes occur at the fracking operations in southern Colorado and Trinidad, in Oklahoma, and in Arkansas. Also, very close to a frac well in Virginia with that 5.9 that struck the East Coast back 2 years ago. That happened very close to a frac well, okay? So, showing this to you, this 4.9 here, we were expecting the movement to occur there. Now, you got to ask yourself, how did I know? Why are we looking in that region specifically? Well, let me take you and show you a graphic here, okay? We'll have to scroll down my page a little bit. If you guys are already aware of this information, it won't come as a shock to you. But if you're a new viewer or you don't understand much about how earthquakes are working these days, and that geology does need to be addressing this, geologists do need to be addressing this at some point, that the Craton here, seen on the right, is being displaced from the northwest. And we're normally taught that subduction occurs here along the subduction zone along the west coast, which relieves the pressure from the Pacific plate. And that the mid-Atlantic ridge over here far to the east, off the east coast, let me get back over to Earthquake 3D, we've got the mid-Atlantic ridge over here, is spreading, okay? And that's pushing the plate of North America from the east to the west. And they think that the rolling foothills of Missouri and the New Madrid seismic zone and the mountains here to the east are caused by the pressure coming from the east. Unfortunately, what's happening recently is that pressure is coming from the northwest, and it's literally spilling, quote unquote, down the edge of the plate. And let's go back over to the Craton diagram here, okay? So we've got our unsubducted edge, and this is a rough diagram from, you could find this in many textbooks, but you can see here that here's the edge, okay, and it's the unsubducted portion that runs just east of the Continental Divide down through Colorado, New Mexico, and then extends south and then east through Texas, right where the fracking operations are, back up through Oklahoma and Kansas where the fracking operations are, east through Arkansas, back down and then up the east coast where we have our other fracking and oil well operations up here in West Virginia. Located right in the middle, we've got another pocket, so to speak, of shale that's developed in a large depression up here in North America. Let's get over to Google Earth now. And up here in North and South Dakota, you actually have a depression of shale that's formed deep down into the crust. So it's kind of like a donut that's been filled in the center. And that's where another fracking operation is. And we see a few earthquakes there, maybe one or two every year, happening even in the center of the Craton, at the center of the unsubducted plate. Even earthquakes are happening there at the fracking operation. Again, pressure coming from the west, northwest, pushing down the edge of the Craton, which right here is Yellowstone. Now that brings us back to the 4.9 that happened today. The 4.9 actually is associated with Yellowstone. And I can prove this to you here. We can just go ahead and search Yellowstone magma chamber 2012. Okay, and what you'll find is that the American Geophysical Union and USGS both came through and did new measurements of the underground magma chamber throughout Yellowstone. And okay, here we are from an EDU source, so you guys don't have to think this is some conspiracy site or something. This is literally showing the new seismic measurements, and this is done via underground radiometric measurements, sending sound waves down into the ground to reflect off the magma chamber. And here's, look at this bottom line here, this is a little easier to tell, or the top. Here's Wyoming, here's Yellowstone, here's Idaho. Okay, this is north and this is south. So down towards the bottom of the screen is west, towards the top of the screen is east, going into Wyoming this way, okay? So the magma chamber here at Yellowstone goes up to the surface where we have all our geysers and our activity. And then it goes down, and this is by depth in kilometers, okay? So it goes down 200, 300, 400, 500, 600, 700 kilometers depth, and it goes to the west. And it extends right over through Idaho. We've got our central portion of the magma chamber at about 200 to 300 kilometers depth right here. And here's the border of Idaho. Now let's go back over, look at Earthquake 3D. Here's the border of Idaho right here. That means that the magma chamber for Yellowstone at approximately 200 kilometers depth is being displaced, and it's causing earthquakes to occur right at the western portion, the furthest western portion of the magma chamber. Now, take that in conjunction with other news, and you guys are I'm gonna put links down below for all of this, so you don't have to take my word on any of this. You can look it up, you can show it to a teacher or professor, your relatives, or you can look it up yourself. And what you'll find out is that the USGS and American Geophysical Union and California Volcano Observatory and West Coast Alaska Tsunami Warning Center actually all involved with studies having to do with the rise of magma chambers occurring on the West Coast. They've confirmed Mount St. Helens, magma chamber, rising. Mount Shasta, magma chamber, rising. Yellowstone, magma chamber rising. And confirmed via GPS measurements As of June of this past year, in 6 months' time, from New Year's till June of 2014, Yellowstone rose 2 inches and was pushed a half inch, guess which direction? Southeast. The same direction that the Craton is being pushed, where it's causing all these earthquakes along the edge of the plate. Let me bring you back over here to my blog, okay, and we're going to look one more time at the Craton diagram here. It's being pushed from the northwest to the southeast. Earthquakes happening here at the western portion of the magma chamber. Earthquakes also happening, you guys may remember, a series of 5.0 earthquakes struck down here at the border of New Mexico and Arizona. And it got a little bit of coverage, actually, and let me just search this out. Arizona, earthquake, volcano, Dutch Sins, just to make it a little easy to find my post. And then you'll find my different post from my blog showing you guys that what resides at the earthquake epicenter is actually a old volcano, a dormant volcano, which even has a monitoring station. And I zoomed in just in case people didn't want to believe, it even has a little monitoring station up on top. Here it is. It's undeniable. It's an old, dormant, ancient volcano. There it is, rising up on all directions. And the rock for sure is an old red, black basalt, an old lava rock, okay? So that's what's down at the edge, at the furthest southern edge. That proves that the whole edge of the Craton has moved from here, up here to the northwest, east through Texas. Let's look at those smaller earthquakes again. And let's turn these down so you can get a good idea of what we're looking at here. Okay, so the earthquakes start up here. 2 big earthquakes push it from the northwest to the southeast, causing movement along the edge of the plate. The only place that hasn't moved yet would be here, and here where the plate curls back up. You can even see it here. We can also go look at actual satellite imagery. Let me turn off my place marks. And let's turn off the states really quick. Okay, you can see how it even curls down here and comes back up. And as it comes back up, you can see the lighter mountain ranges here to the east. And that's where we've got all of our fracking operations. Then the edge of the plate really becomes defined. And let me turn off the roads. And let's turn off photos and places. Then you can really see the edge here. Okay, and these are the Appalachian Mountains. Curls down through the south, goes back up to the north just by a little bit through those fracking operations in Arkansas and Oklahoma, and then back to the west, dips back down to the south, goes back up here to the northwest. And that's, again, all given away by the diagram that I've been showing you throughout this video of the Craton here. Okay, so you can just follow that. That matches up perfectly with what you see on satellite imagery. It just so happens that the area along the edge is being displaced earthquake-wise. Okay? So, that whole explanation leads way to, can you forecast an earthquake? Can you predict where an earthquake is going to happen? Well, it sure seems like I just did that over the past several days and over the last several months and years if you guys have been a viewer. Now, the USGS and professional seismologists came out 2 weeks ago issuing a statement via public media that addressing earthquake forecasting, specifically because of a post that I made that was sent directly to them regarding an earthquake happening up in Vancouver, British Columbia. And they made the claim, again, yet once again, as of 2 weeks ago, that earthquakes are not related to one another over a large distance. Now, before I made all these posts, before the post on the 1st, predicting this earthquake here, the 4.9 in Idaho, and the other earthquakes, there was the original 5.1 in California, down here near a drilling operation, a fracking operation, right along the fault line, just south of Los Angeles, found the names of the wells, found the names of everything, and said, what we need to do now is watch the area just to the northwest. We need to watch the area just to the northwest. Said this over and over again for the last several years. When we see a cluster happening, we need to watch the area to the northwest for the movement. That then kicks off the rest of the movement across the plate. It happens everywhere, not just in the United States. It happens overseas. We'll see earthquakes happen here, these deep earthquakes that you see risen far off the globe. The higher they are off the planet, the deeper they are into the earth. So these are a series of deep earthquakes happening here around a volcano. That's pretty interesting to look at. There's great footage coming out of there. But we'll see earthquakes happen here, and then further to the west, northwest, following these earthquakes, we'll see shallow, larger earthquakes. So let's look at the earthquakes 5.0 and greater internationally. Okay, let's get there. There we go. So we're looking at everything 5.0 and greater over the last 7 days. And you can see there's been actually a 6.0 that struck that kicked off all this flurry of 5.0 movement to the northwest. First the 6.0, then a series of 5.0s to the northwest. And we saw here in California, 5.4 here, originally 5.1, then followed by the 5.2, then pushing the plate to the southeast by who knows how far, but causing earthquake movement in that 4.0 range happening at the western chamber of Yellowstone, which is clearly just being displaced by the pressure coming from the northwest. What we can expect in the United States going forward over the next several days, now that we've seen the 4.9 here in western Yellowstone, we definitely need to watch for larger movement in Trinidad, Colorado, and that's right at the border of Colorado and New Mexico. Also, Greeley, Colorado, and we need to watch south central Kansas, not normally known for earthquake activity, for 4.0 or possibly greater activity. Also, over the last 7 days, the East Coast pretty much has been entirely silent with all this pressure happening to the northwest, releasing down here at the fracking operations. We can expect that the displacement will compensate to the further east and by northeast along the edge of the Craton. Back over here, edge of the Craton, turn on the states, and that'll let you know where we need to watch. So this area is already moved. This area is currently moving. This is putting pressure down here, which is causing earthquakes, but this will eventually get to the point where it can't keep up with the pressure from here, causing fracturing at all the frac wells unexpectedly. That will eventually spill to the north by northeast. And we've seen it happen before, when there was a series of 4, 3, and 4, and 5.0 earthquakes happening along the edge of the Craton to the west. There was the 5.9 that struck here to the east in the same day. 5.0 happened here in Trinidad, Colorado. 5.9 struck here on the East Coast and caused all the damage to the Washington Monument. Everybody made note of it. They did not make note of the 5.0 that happened the same 24-hour period here at the fracking operation in southern Colorado, which is equally as big, by the way. In case you guys are wondering how big these operations are that I'm talking about here, previous earthquakes have happened, and I've only managed to mark just a handful, and I mean just a handful, of the possibly tens of thousands of wells that have been drilled here. You can imagine those are all perforations that go down into the crust somewhat, some by up to a mile or two, where they've drilled down, and those are like tiny drills into a solid tooth. You can imagine your tooth is solid and you take and puncture it by 1,000, 10,000 points, that there's going to be a fracture on it when pressure comes in from an unexpected direction. But you may not have planned the fracking operations to be pushed from the northwest by inches in 6 months' time. Let's say 2 inches at Yellowstone rise in 6 months' time, 1/2 inch push to the southeast in 6 months' time. If that carries true, that would mean 1 inch push to the southeast in a year. That would push all the fracking operations as well. And we saw, again, you guys have to be paying attention to this information. We saw a series of large landslides, and even in western Colorado at a fracking operation, a huge ground burst where liquid sand, high pressure liquid sand, blew out of the ground. They tried to call it a landslide until it just became obvious that it wasn't, and they dropped the story. But it was a fracking operation with high pressure liquid sand that blew, and it blew down the mountainside. And it literally rolled out liquid cement sand across the entire landscape, over hills, over mountains, literally over mountains, over several thousand feet high. It put up a tidal wave of liquid sand, which they tried to say was a little lake up on top that broke. Now, that was a cover story for the pressure that was occurring, because at the same time, you had another collapse just to the north, just south of Yellowstone at Jackson Hole, where that whole mountain fractured in half. You guys remember that? And then the landslide up here at Washington State, which was all of these were preceded by 1.0 earthquakes, by the way. Each one preceded by a 1.0 earthquake. Each one of those large landslides. Go look it up, guys. You do not have to take my word for it. Do I have time to go pull all the links for you? I don't know. But I'm going to put as many as I can down below. That all being said, you can forecast an earthquake down to a specific region, down to a specific time. Beyond that, naming a town, naming a specific state, that is to a point where I think it's going to require some serious supercomputing. It's a mathematical formula to try and figure out how this ping pong effect of pressure that's going back and forth between areas is related. And to stop denying that it's related because of old dogma taught from the 1800s that one earthquake cannot possibly be related to another, it's too far of an area, there's too many fault lines. Well, one fault line is indeed putting pressure on the other, documented it, no doubt about it. You guys can come over to my website. Again, you can come over to my site anytime you want and verify any of this information. I try to document it as fully as possible. This past 24 hours, this was just on the 1st, so 2 days ago. This is 24 hours of earthquakes. They started, bounced over here, produced the 5.1, came back the other way, equidistantly spaced. Equidistantly spaced. You can watch it. The animated GIF does not lie. And that's probably why this post actually went right to the top. This one actually got shared. The most out of any post that I've ever made, just showing and stating that this turns all of geology and seismology teaching on its head. And it does. It refutes a key point that many people still repeat as fact when it's just a dogma, it's a teaching, it's a theory of their own that's now been disproved. And it's disproved not by me so much as the facts. The facts prove that earthquakes are related to another. You can see them pop off. And this is all due to newly available tools. Before there wasn't an earthquake 3D. And I challenge the USGS at this point. Look, you guys can suck it up and make your own version. It's okay. You don't have to be like Dutch Sense. You can call it the USGS Earthquake 3D Globe and show everybody where earthquakes occur and make it double clickable so you can open it up, get the coordinates, and go look them up yourself. It's easy. It reveals a lot. Now that might be a problem for certain powers that be that help finance the USGS and other earthquake-related agencies. They may get a certain portion of their funding from the oil industry and gas industry, which we are reporting on. That could be a possibility. But at some point, science must prevail over politics, guys. And if you're a USGS scientist, or if you're a professor, or you're a teacher, or you're a student, it requires you to, I guess, take the stand, take the fall. I don't know. I mean, I'm not asking you to put your education and your profession online, but maybe start to accept these things personally. Start to look into them. Start not to believe every single thing that you see written in a book, because a lot of the things that are written in your textbooks are either wrong or incorrect assumptions based upon incorrect data. So they could be perfectly right in their own mind with the incorrect data, but it's starting out with incorrect data. So you're starting out with an incorrect theory that one earthquake isn't related to another. So you're actively denying it when an earthquake occurs along the edge of the Craton right after the Craton is pushed from the west. Just simple. Okay, so it just requires you to throw out something that you were taught that it turns out wasn't true. And needs to be adjusted at an educational level. And I think this is probably, in the 21st century, the most appropriate way to do it, is just to correct it publicly, put it out there for you guys to review, and you can make up your own mind. You don't have to call it the Dutch sense theory. You can call it your own theory. You can write your own doctoral thesis on it, and just send me a little thank you card when you're all said and done, guys. Okay? Much love. Be safe. Always have an earthquake plan ready and be prepared just in case, because you never know when it could strike. As a person who lives in the New Madrid seismic zone here in St. Louis, Missouri, it's always good to have a plan. Because when you see this kind of movement happening here, you know that when that 5.9 strikes here and the things are falling off your shelf and your TV's falling over and the Washington Monument's fracturing while you're inside of it, that you are prepared.